In this exercise, we are going to see one of the possible methods for finding out the angle bisector of the angle that two straight lines form when, as we can see here, they meet outside the boundaries of the drawing area, which means that we cannot use the method we have already seen. In order to solve this exercise, we have to use the definition of angle bisector, which is the line where each point is the same distance to the straight lines that form the angle. So, if we find several points that are the same distance to both straight lines, they will belong to the angle bisector of the angle, and this angle bisector will be the line that goes through those points. Although we should find 2 points, because 2 points determine one unique straight line, we are going to simplify the exercise a little, without forgetting its essence, that is, finding points that are the same distance to both lines. In order to do so, the first step is to draw a straight line that is parallel to line A at any distance. Then we will have to draw another line parallel to line B at the same distance. Both lines we will have drawn will meet at one point that will be the same distance to the lines that form the angle, so that point will belong to the angle bisector they form. In order to draw a line that is parallel to line A, we have to draw a line that is perpendicular to it wherever we want. This straight line R, perpendicular to line A, meets line A at point A. From point A and on line R, we take the measure we want, for example, this measure D, marking this point A the first on straight line R. Then we draw this line A the first that goes through point A the first and is parallel to line A, so every point on this straight line A the first is the same distance to straight line A. Now we have to do the same on straight line B. We draw a line that is perpendicular to line B wherever we want. This straight line S, perpendicular to line B, meets line B at point B. From point B and on line S, we take, using the compass, the same measure we took before, marking this point B the first on straight line S. We have to draw now this line B the first that goes through point B the first and is parallel to line B. So every point on this straight line B the first is the same distance to straight line B. If every point on straight line A the first is the same distance to straight line A and every point on straight line B the first is the same distance to straight line B, and the distance is the same on both cases, this point where straight lines A the first and B the first meet will be the same distance at the same time to lines A and B, this point P. We could repeat the steps with another measure, different from the last one, in order to find another point Q that is the same distance to both lines, but a different distance from the one at point P. However, it is enough with drawing the angle bisector of the angles that lines A the first and B the first form at point P. Using point P as center and the radius we want, we draw an arc that meets lines A the first and B the first at points 1 and 2. Using points 1 and 2 as centers and the radius we want, the same in both points, we draw 2 arcs that meet at this point 3. The angle bisector of the angle that lines A and B form when they meet out of the boundaries of the drawing area is the line that goes through points P and 3.